Hello, welcome to your new class. Today we will go slightly in a different direction and we will be discussing how the Android processes and threads work when we are running an application and how does Android manages activities, services and other things in terms of processes and threads because these are the basic units of execution and we will try to use and understand how does the activities, app component, anything in an Android application works in terms of processes and threads. So let's get started. Processes. Now let me remind a little bit from your operating system course. In operating system course, we normally study something called a program, a process, and a thread. Can you recall what these were? Okay. So a program usually is nothing but just some lines of code which are written. A program in execution is called a process, and a thread is a line of execution. So process is something which is alive while program is not. And thread is something which is a line of execution. There could be multiple threads in the same process, or they could simply be one thread. There will always be one thread, but then there could also be multiple threads. So let's start now with our Android operating system. So in Android, by default, all components of the same application run in the same process. However, if you need to control that which process a certain component belongs to, you can do so in the manifest file. There is an attribute given Android process and that helps you achieve your aim. Now, Android might decide to shut down a process at some point of time when the memory is low or required by other processes that are more immediately serving the user. Now, when Android decides that, then any application component that is running in the process is killed, as we can understand. And uh, the when there is a work to do, then the process is started again for those components. So, because we are working on a mobile platform where the resources are very scarce, the Android system may try to kill some processes, and but if those processes are needed, then those processes will be restarted. For a normal desktop, Linux, it does not really have to do this because there are plenty of resources. Now let's understand the process lifecycle a little bit. So the Android systems try to maintain an application process for as long as possible, but because there could be multiple processes, the system needs to eventually remove old processes to reclaim memory for new or more important processes. Now, this is a decision which is similar to what, for example, in operating system, usually uh, you may have studied about schedulers, and in case of scheduler, the scheduler needs to decide which process to run. And similarly for the memory page faults, sometimes the processor has to decide which pages to throw out. So these are some decisions which are made throughout in the system in different stages. So for Android, in order to determine that which process to keep and which to kill, the system places each process into a kind of importance hierarchy, which is a hierarchical list. And because it's a hierarchical list, the items at the bottom of the list will have more chance to getting killed than the items on the top of the list. So there are total 5 levels in this importance hierarchy in an Android operating system. So let us try to see what those 5 levels are. So the first or the topmost level is the foreground process. That is the process which is currently in the foreground, process that is required for what the user is currently doing. Now, this process is obviously the most important process, and that's just the reason that the foreground process are on the top of the hierarchy, and these processes have a very less chance of getting killed. Now, what are the conditions in which a process is considered to be in the foreground? So here are some following conditions. And if any of these conditions is true, we assume that the process is the foreground process. So number one, process hosts an activity that the user is interacting with. So that basically means that there is an activity which is currently active, visible to the user. So the process that is hosting that activity is considered a foreground process. Similarly, the process that is hosting a service that is bound to the activity that the user is interacting with. Third is that it is hosting a service that is running in the foreground. So in last lecture, we learned about services which usually runs in the background, but services which can also run in the foreground. So if there is a process which is hosting a service that is running in the foreground, the process is also considered a foreground process. And then a process that hosts a service that is executing one of its life cycle callbacks. So when a service is executing one of its life cycle callbacks, at that time the process that is hosting is considered a foreground process and gets the highest priority. And then the process which hosts a broadcast receiver that is executing its own receive method. Now, one thing that is common that you may have observed is that the foreground process is directly linked to the current activity that is going on the device. So whether it is in form of an activity or in form of a service or in form of a broadcast receiver, etc., etc. So because as you see in the mobile, you can see that there would only be very few foreground process at any given time. And foreground processes are only killed as the last resort, which means that if the memory is so low that the Android system has to reside within the foreground process, then only foreground process will get killed. And if the system doesn't kill, then the user interface will become non-responsive. So foreground process is killed only if and only if there is no other resource available to make sure that our Android application remains responsive. So the after the foreground process, the second type is of the visible process. So the visible process is a process that doesn't have any foreground component, but still can affect what the user sees on a screen. A process is considered to be visible if either of the following conditions are true. So for example, if the process hosts an activity that is not in the foreground, but is still visible to the user. For example, an activity which is called on pause method. This might occur, for example, if the foreground activity started a dialog which allows the previous activity to be seen behind it. And the other condition in which a process could be considered as a visible process is that it hosts a service that is bound to a visible activity. So in either of the case, we will call that the process which hosts such an activity or a service is a visible process. So just like the foreground process, a visible process is also considered extremely important and will not be killed unless doing so is required to keep all foreground processes running. So visible process priority is very high, but not as high as foreground. So it will only be killed if there's no other option than killing it or killing a foreground process. So between the foreground and visible, the visible has the lower priority. The third type of process is what is called a service process. A service process is a process that is running a service that has been started with the start service method and does not fall into either of the two higher categories. The higher categories were the foreground process and the visible process. Now, although these service processes are not directly tied to anything the user sees, they are generally doing the things that the user cares about. For example, downloading a file or playing a music. Now, these are some services which, if they are running and if they stop, then you will not like the app. So that's why the Android doesn't try to kill a service process either, and it tries to keep them running until there is not enough memory for the foreground and visible. So unless there is a such a memory crunch that it has to decide between killing service and a visible or a foreground, it doesn't kill the service process either, because service process is also going to affect the user experience. The fourth type of process is the background process. So background process is a process that is holding an activity that is not currently visible to the user. For example, an activity whose on stop method has been called. So if you see, then we are going from an activity which was the active visible activity till the activity for which the on stop method has been called. So these processes have no direct impact on the user experience, the background process, and the system can kill them at any time to reclaim memory for a foreground, visible, or service process. Now, as you can imagine, that usually there are many background processes running. So they are kept in an LRU list. LRU list is the least recently used list. You must have studied in the operating system. In a least recently used system, a priority list is made depending on what was used least recently. That is, the one that has just been used comes on top, and the something which has not been used recently comes at the bottom, and then the processes or pages which comes at the bottom are removed. So similarly, if the background processes in Android are kept in an LRU list to ensure that the process with the activity that was most recently seen by the user is the last to be killed. So if there is a process associated with an activity which was just seen, that process will not be killed compared to the process which is associated with an activity which was seen some time back. So that's how the LRU works. Now, if an activity implements its lifecycle methods correctly and saves its current state, killing its process will not have a visible effect on the user experience. Because when the user navigates back to the activity restores all of its visible state. The fifth type of process is what is called empty process, and such a process doesn't hold any active application component. The only reason for having an empty process is to for caching purposes. That is, you want to improve the startup time the next time a component needs to run in. So system often kills these processes in order to balance overall system resources between process caches and the underlying kernel caches. So empty process is just an attempt by Android operating system to optimize, and if there is any need, then these processes are killed. Now let's come to threads. As you have studied in your course on operating system, threads are nothing but a line of execution. In operating system, we also study what is the difference between process and thread, and normally we see that, you know what, threads do have their own stack and their variables, but they share few things. For example, they share the heap with with other threads of the same process. So here let us try to see that what are threads in the Android operating system. We just studied about processes, now we are going to study about threads. So in an Android, when an application is launched, the system creates a thread of execution for the application, which it calls main. Now this main thread is very important because it is in charge of dispatching events to the appropriate user interface widgets, including drawing events. Now, it is also the thread in which your application interacts with components from the Android UI toolkit. And main thread is also sometimes called UI thread. So UI thread or main thread are the name of the same thread. The system does not create a separate thread for each instance of an component, and so the all components that run in the same process are instantiated in the UI thread or the main thread only. And the system calls to each component are dispatched from that thread. So as you see that there is only one thread which is doing a lot of work, which is letting the app component interact, creating other useful activities, for example, interacting with components from Android UI toolkit, is in this charge of dispatching events, etc., etc. So this is a thread which is really overloaded. So what is the effect that happens? Well, when your app performs intensive work in response to, let's say, user interaction, the single thread will yield poor performance because there is only one thread and there is just too much work to do. So if everything is happening in the UI thread, performing long operations such as network access, etc., will block the whole UI. So suppose you want to start downloading some file, or you want to start doing some network access, because this is only one thread, it will block. And when a thread is blocked, no events can be dispatched, including drawing events. So for the user, it looks like that the application has hung. Now, the problems don't end here. If the UI thread is blocked for more than a few seconds, you see the infamous dialog which says application not responding. So you may have seen this multiple times, and that usually happens when your UI thread is too busy to work, and then it can't really refresh the UI for more than 5 seconds, and Android gives us the warning. And if your application gives such a warning, then the users may just want to uninstall your apps. Now, another important thing about threads. The Android UI toolkit is not thread safe. So you must not manipulate your UI from a worker thread. You must do all manipulation to your user interface from the UI thread. The thread safe or not thread safe, you may have studied in the operating system, but let me revise it. A thread safe is something for which on which multiple threads can work simultaneously, and you are assured that the consistency, etc., will be maintained. But a non-thread safe is something where such consistency, etc., is not maintained, and it is the responsibility of the developer to do it. You may have already read many synchronization primitives and synchronization algorithms, for example, Peterson's algorithm. We may have studied about semaphores, monitors, etc. So all they were to ensure that you can use multiple thread in such a manner that it looks like that everything is thread safe. So if you are a little weak in understanding what is thread safe, please try to go back to your operating system books. So let's come back to the Android. So there are simply two rules for Android single thread model. Number one, don't block the UI thread, that is, don't do anything which is CPU intensive. And number two, do not access Android UI toolkit from outside the UI thread, because it is not thread safe, and when it is not thread safe, you never know what can happen. Now, let us study a little bit about worker threads. So worker threads are also called background threads, and if you have operations to perform that are not instantaneous, for example, let's say downloading or uploading something, or updating complex UI, then you should make sure to do them in separate threads. So let us see a small example of an on-click listener. In this, there is a on-click listener. I start a new thread which loads an image from the network and then sets the image bitmap. Now here we are using a separate thread to do this work and not the main thread only. So we start our new thread, which we call as worker thread here. Now, it may look to you that this is perfectly fine because I'm using a worker thread. Let's go back one more slide, and we said, do not access the Android UI toolkit from outside the UI thread, but this is exactly what we are doing. So this is not our UI thread, and we are manipulating the UI toolkit. So let's try to find out a better way of doing it, and Android definitely provides better ways. So let us look at this example. In this, we again start a worker thread. We do the load image from network, but then we are doing something else. We're doing mmageview.post, which we were not doing earlier. So the view.post is something which fixes this problem because uh, the network operation is done from separate thread, while the image view is manipulated through the UI thread. Now this is possible because we were able to do using the view.post, we were able to do it. However, as these things becomes complex, it is not always very intuitive to find out the right method. So in order to overcome this, Android provides us something which is called AsyncTask. So the async task allows you to perform asynchronous work on your user interface. The asynchronous work is something which does not wait for it to finish. In simpler words, so async task performs the blocking operation in a worker thread and then publishes the results on the UI thread. So basically, it's a combination of UI thread and a worker thread. When there is a too much of blocking operation, that is done on the worker thread, and then the results are pushed to the UI thread. So your conditions for not touching UI toolkit other than the UI thread is fulfilled. At the same time, it also makes use of the worker thread to improve the performance. How do we use it? We must subclass async task and implement the do in background callback method. That's it. And for updating your UI, you should implement on post execute, which delivers the result from do in background. Now let's try to see a simple example to understand it. This is the same example that we were doing earlier, except that this time we are doing it in the method called do in background, as we said earlier. And this time we are doing the set image bitmap, but because we are doing it in do in background, it is fine. So here we are, and everything is okay. So in async task, you can specify the type of parameters, the progress value, and the final value of the task using generics. The method do in background will execute automatically on a worker thread, and on pre-execute, post-execute, and progress update are all invoked on the UI thread. So the value returned by do in background is sent to on post execute, and you can call publish progress at any time in do in background to execute on progress update on the UI thread. So as you see that the async task is providing you a very good mechanisms to move from worker thread to UI thread and UI thread to worker thread. Async task we will cover in detail in later chapters. Today we are only giving an introduction. So this was all about processes and threads in the Android. This is to put you in the same context as any other operating system. The concepts are very much same because Android is indeed based on Linux operating system. We will in the next few lectures, we will be doing a lot of programming to understand all these concepts and discuss them in detail. Thank you very much.